So here's a brief discussion about the solution to this last problem on the related rates worksheet. So you have this tire, right? And it's spinning clockwise, so this way. An ant gets smashed at the bottom, and the diameters of the tire is 50 centimeters, right? Which means the radius is 25. And so you want to know how fast is the ant rising when its height above the ground reaches 37.5 centimeters, right? So how fast is it increasing in height? And the other bit of information we're given here is that 1 revolution is 0.1 seconds. So method 1 in this problem, which we were discussing in class, is we find a function f of t for our height after t seconds by appealing to sort of, sinusoidal function stuff. And we came up with several formulas for this in class, and I think that the easiest one to actually use in the end is negative cosine. Although if you do sine, it's possible, but as you saw, solving for that time t gets a little bit more complicated. So let's say we've chosen this cosine function for our height. Well, our goal is to find f primed of t when f of t is equal to 37.5. Okay. So that means we need to first, do two things. First, take the derivative of f, that's the easy part. But second, which is the more complicated part, is figure out this time t at which this is true. All right. Now, if we plug in 37.5 for f into our formula here for height, right? We can subtract 25 from both sides and divide by negative 25, and we come up with the formula negative 1/2 should be cosine 20 pi t. Okay. Now let's think about where this happens on the unit circle, right? So we know that cosine in the first quadrant is equal to 1/2 at an angle pi over 3. So if we reflect that into this quadrant, we know that cosine is equal to negative 1/2, right? X goes to negative x at an angle 2 pi over 3. But the other quadrant at which cosine is going to be equal to negative 1/2 is down here, right? At an angle 4 pi over 3. So the question is that since cosine of theta is negative 1/2 at theta equals 2 pi over 3 and 4 pi over 3, and in fact, adding 2 pi to any of these, which one should we choose here when solving for t? Well, I think that the best way to think about this is to compare it with the actual application where, remember, we're starting here and we're trying to figure out an angle in that direction. So if you think of like taking this and sort of rotating it to get the unit circle here, right? What we're really doing is we're going into the second quadrant of our rotation. And so to figure out the angle here, we should also choose the value that appears in the second quadrant. So we choose theta equals 2 pi over 3, right? Set that equal to 20 pi t, and we solve for t to get that t is 1 over 30. And so now we do the easy part, the calculus, which is we compute f primed of t, which from our earlier formula is going to be 20 pi times 25 sine 20 pi t, right? And then we just plug in t equals 1/30th, right? And when we do that, we would get 20 pi times 25. Now here, notice that this is going to simplify to sine of 2 pi over 3. And sine of 2 pi over 3 is root 3 over 2. So we ended up getting root 3 times 250 pi. And the units for that then would be centimeters per second, right? So method one is nice to go through because it gives you practice in writing out formulas for trig functions and also for solving for specific times, like solving equations like this for t. It's challenging though because of the orientation of our circle. Since we're starting at the bottom, which is not how we're used to think about the unit circle, we sort of need to reorient everything from sort of that vertical axis, right? So method two does away with actually figuring out a formula for the height, at least in terms of t, and instead computes a formula for height in terms of the angle theta, and uses a related rates type approach to the problem. So what do I mean by that? Well, another thing we could do is if we draw our picture of our tire again, right? So I know that at this corner, the height is 25, and the height keeps increasing here, right? And when this angle in the center is theta, this is always the radius of the circle, which is 25, which means that this side would be 25 sine theta, right? It's the opposite side of theta here. So my height as a measurement of that angle theta right there is going to be 25 plus 25 sine theta, right? Now, this right here gives me a relationship between h and theta. If I want to kind of use a related rates type approach, the next thing I would do is I would differentiate this expression with respect to t, right? With respect to time, right? So on this side, we would get, we have h as a function of theta, so we want h prime, and the derivative of 25 is 0. Here I would get 25 cosine theta, but then times theta prime, right? Using the chain rule there. Okay. So the question is, all right, well, now this is easier to solve for because this angle theta, right? If I want to end up making up half this distance, I can figure out I need to make up half this vertical distance. I know that this angle theta should satisfy sine theta equals 1/2, right? Which just means that theta should be pi over 6, right? In this case. So I can plug in pi over 6 here and get cosine, right? Cosine of pi over 6 is root 3 over 2. The question is, okay, well, what is theta prime? Well, to find theta prime, we note that it takes 2 pi radians to make 1 revolution, and it takes 0.1 seconds to make 1 revolution. So d theta dt is 2 pi over 0.1, which ends up being 20 pi radians per second. So we take that and we plug it in here, right? And we once again get our 250 root 3 pi centimeters per second for the height. So you can see that this was a little bit simpler. You still had to think a little bit about how to figure out the right angle here. Okay, either one of these approaches would work, and understanding them both kind of helps you understand different angles of this problem, no pun intended.